Hi everyone, I'm here with your 813 lesson, What Patterns Can I See? Linear and Exponential Growth. Patterns in tables, graphs, and expressions give clues about the kind of growth that is being represented. Today you will work with your team to identify whether a table, graph, or situation represents simple interest or compound interest based on the kind of growth that is shown. You will also compare the different kinds of interest in situations to see which one is a better deal. By the end of the lesson, you should be able to answer these questions. What are the patterns in tables, graphs, and expressions for each kind of interest? What are the differences between the two kinds of interest? How does the pattern relate to how the amounts are grown? 824. John needs to borrow $250. Sorry about that. Quick pause. So I'm going to start over. John needs to borrow $250. Moneybags Municipal Bank will charge him 8% simple interest each week to borrow the money. Scrooge Savings will charge him 6% compound interest each week. With your team, help John decide which loan is the better choice. Make a table for each bank. The table should show the amount John owes after each week for 12 weeks. So, this is Moneybags. And this is Scrooge down here. So when we make our table, this is going to be weeks over balance. Again, weeks over balance. So go ahead and try and fill out your table. Let me help you real fast. Hold on, pause 1 second. So we know $250 times 8% interest would give you $20 each week that's added. That's going to be for your simple interest. But for your compound interest, you need to do $250 times 1 plus your interest. Hang on 1 second. Times the number, or to the number of weeks. So that's T, because you don't know how many weeks yet. You're trying to figure that out. Okay? So now use that to help you fill in your table. If you're back with me, you filled in your table, so let's take a look. So Moneybags Municipal, we're adding $20 each week. So this is increasing by 20 all the way up to $490. Scrooge Savings, we're growing by 6% compound interest each week. So it's increasing $250 to $265 to $280.90, etc., etc. Okay, I'll leave that there for a second. B says graph both tables on the same set of axes. So use these tables right here, and now you're going to graph them on the same set of axes. If you're back with me, you have graphs, so let's take a look. Whoops. So here is the graph. Notice Scrooge is kind of has a curve, and Moneybags is going up the same each time. So part C of your problem says, which bank will charge him more if he pays the loan back in 12 weeks? Should he choose the same bank if he plans to pay back the loan in just 4 weeks? So using your table, you need to figure out which one is going to be better. So go ahead and try and answer that. If you're back with me, you've answered C. So after 12 weeks, he owes Moneybags $490, but he owes Scrooge $503.05, which would make Moneybags the better choice. After 4 weeks, he owes Moneybags $330 and Scrooge $315.62, which would make Scrooge the better choice. Okay, and all that information just came out of your XY table up here in part A. So D says, simple interest is an example of linear growth and compound interest is an example of exponential growth. Talk with your team about how you could explain to someone else the difference between the two kinds of growth. So hopefully you've been able to see that linear growth grows by adding the same amount each time. That the X value increases. Exponential growth grows more and more each time the X value increases. Okay. Finally for today, 827. Tom had a choice between borrowing $250 from his grandmother, who will charge him simple interest, or borrowing $250 from the bank, which will charge him compound interest at the same percentage rate. He plans to pay off the loan in 8 months. He wrote the two expressions below to figure out how much he would owe for both loan options. A, what percent interest will he be charged? Where can you see the rate percent in each expression? So in the first expression, he has $250 times 1 200ths to the 8th because he's going to pay it off in 8 months. So we see this here. Okay, we know in compound interest, our interest is right here, but we have to subtract 1 from it. We would get 200ths. We have to multiply that by 100 to get 2%. So 2% is what he will be charged in the first one. In the second one, we have 250 plus 8 times your interest rate. So the $5 represents the $5 in interest in the second expression. Okay, so if we did 0.02, which is 200ths, times 250, that would give us $5. B, which expression represents the amount he would owe his grandmother? Which one represents what he would owe to the bank? So remember, simple interest is grandma, compound interest is the bank. So go ahead and try that. If you're back with me, you've tried. The grandmother would be the one over here on the right. That is your simple interest because you have just the interest of $5. And so that would make the bank the one on the left. C. Evaluate each expression. Should he borrow from his grandmother or from the bank? So go ahead and try that. So from the bank, when you put that into your calculator, you would get $292.91. And from grandma, it would be $290. So therefore, this is the lower amount he should borrow from his grandmother. Okay, that's it for today. If you have any questions, please make sure you email us.